So, Mr. Bunch, I have tested your SCRs. They both appear to be working. Look here at 12 volts. I know you're at 90, but these things are rated for 200, so that's cool. And I used a light bulb in place of your motor. And the T1 Triac, that's your SCR. A is the stud side, K is the cathode, the big lug on the other side. G is the smallest little lug. And what that is, a Triac and SCR is just a switch. It's like a relay. It's off until you tickle it with 2 volts at G. It just takes a millisecond and it turns on until you drop power to the circuit. In our case, the circuitry all on the board is just a timer. It sends, probably based on the sine wave, it sends that 2 volts on G, it turns it on, and it stays on until the switch SC or S2. In this case, it's just when the sine wave drops to 0 voltage, it turns off, and it will not turn on again until G tickles it with 2 volts. So we'll get to how that works and what it's doing for you. So somewhere in your circuit, we're turning your AC, the sine wave, into DC. We use one diode. I suspect that's the little round things, the radial fins, and it just chops all the negative electricity on the bottom of the sine wave. It just ignores it, it just won't let it pass through. And this is half-wave rectification. I'm guessing they use 2 of those diodes, little round things with the radial fins coming out of them, to do full-wave rectification. You get twice as many positive pulses as you would with half-wave. Even though it's still a pulse, essentially at this point your motor sees DC. There's some loss there, so it's 90 volts roughly instead of the 120 volts you started with, but it is DC as far as a motor sees it. So that big green capacitor that does what they call smoothing on this. That's why it's a time thing. So that's where you lose your a little bit of voltage. It goes from 120 to 90, which is what your motor wants to see anyhow. That's what it's designed for. With the capacitor smoothing, your motor doesn't see from 0 to 90 to 0 to 90 to 0 to 90 over and over again 120 times a second. Capacitor smooths that out, and you've pretty much got a straight line of 90 volt DC electricity available to your motor. A little rheostat you have right now, again, low current, low voltage, and all that's doing is changing the delay of the pulse you give it. So the rest of your circuitry doesn't see the high power loads. It's low current, low voltage, and all it's doing is varying the delay and sending that pulse to the SCR to turn it on. The longer the delay, the less of the sine wave is there, the lower the voltage that the motor sees, and therefore it goes slower. You have a short delay, and you have almost all the peak of the sine wave available to you, and therefore a higher voltage, and the motor goes faster. See? There's other things that the circuitry does. It ramps up the voltage slowly, so you get a soft start. It doesn't put a lot of wear and tear on your motor and your gear drive and everything else. It starts with a long delay, and within a few pulses it gets up to the shorter delay, which gives you more voltage in your motor and a faster speed. It also has some current protection, which is probably designed to save your SCRs in the case where you're trying to run the motor through the brake, but obviously that didn't work, so it puked the SCRs since they sold almost infinite current when it was stalled. It also probably has a job to do in relation to your 2 position switches that are up in there as far as reversing the motor whenever you throw that direction switch, and maybe keeping it from jerking from forward to backwards all at once and cramming up your gears and such. And the only reason I'm telling you this is because why couldn't we just do it with a big rheostat? Well, a rheostat is just a big resistor. Resistance is heat. A lot more cost. It'd be a pretty damn big rheostat versus the little microamps you're dealing with now to send that little two volt pulse, low current, and the heat again, resistance needs bigger wires, more current, bigger outlet, more amps to drive the whole thing. It's just not feasible. And when you can do it with the electronics and just chop the sine wave and just give it a little bit at a time, see? You might need bigger fuses. Hell, maybe some 12s, 15s, 20s. The worst could happen is you burn it all up. My fuse selection was based on what a modern day drive uses to run a 4.6 amp motor, 8 amp slow blows. Hopefully that will be sufficient. This being older, it it does things, probably takes a little more power, so I'm not really sure. It was all guess on my part, but use the 8s first. I hope you took a good picture of all your wires so you can get them back in the right location and mark them well. Otherwise, things will smoke. I guess the only other thing that could have happened is whatever rectifies the AC and the DC, whether it be my guess at those diodes. But the rest of the timing circuitry, it never sees the big current. It's just sending that little pulse to turn the SCR on. So I think that should be okay. Hopefully this does it for you. And in the future, don't ask questions if you don't want the answers. Bye-bye.